want to thank you all for being here. We're here to help companies get started, develop their products, uh, develop a plan, raise investment, and get their products to market. And in light of that, we're going to be having a webinar in the near future on our pitch tape portal, and we'll talk more about that later. But it will enable companies to pitch to investors, and it's open to a lot of entrepreneurs throughout the community. So we'll talk more about that later. But I want to thank you all here, and especially uh, for the RDM, who has done an awesome job with prototyping. We've been working with them for I don't know how long now. It's been a couple of years now, something like that, Dominic. And uh, they do a first class job, and we're excited every time they've done a webinar in the past. It's always been very exciting, and they have a lot of cool things to show us. So Dominic, welcome to the webinar, and we're looking forward to your presentation, and thanks for being here.
Yeah, no problem. Thanks for having me. Yeah, we know each other the past couple of years, and we've been expanding, and you guys have been growing, and it's been really awesome. Hopefully we can do some more webinars in the future. Most of ours are based on product development, if you guys have been here in the past, because that's what we do at RDM is product development, like the back-end services. We're a group of engineers that has access to various machines. But today, appreciate all of your guys' time coming. Appreciate IPDC for having us, and we'll get into it. It's about 20 slides long. I expect to be about 30-ish minutes of content. Feel free to interrupt me whenever you want. You can either, raise the hand in the chat, or, just blurt out. It's all good. I'm here for you guys. And I know that product development is very wide. Some of you may be working on apps. Some of you may be working on hardware. Some of you may be working on just electrical. But I expect most of you guys have an interest in what we got going on today. So if the content isn't matching up with what your expectation is, feel free to interject, ask questions, and I'll do my best to answer them. But today's topic is really kind of trying to, first off, explaining what product development is in a very broad 30,000-foot view, then going into these two different buckets of prototyping and production. These are both pre-market activities. If you want to make them a one singular activity, which is really hard because there's like thousands of different activities into each bucket. But, these are all before you sell your first product, that these details should be figured out. Not saying that that's how it happens. It's entrepreneurship. It's sort of, a lot of the stigmatism behind what we're going to talk about today is throw it at the wall, see what sticks, pivot, adapt, blah, 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 blah. But to try to be rigid, try to have structure is something important. But my name is Domenic. I founded RDM Innovation along with a couple business partners in 2015, moved to Gainesville from Sarasota. We're now 8 people strong, 6 engineers, a few contractors, graphic design, marketing. And we're going to start today by talking about what is product development. So it's kind of funny, but product development is what RDM stands for, quite literally. It's research, it's development, and it's manufacturing. That is the whole picture of what product development is. Kind of alluded to it before. It's the pre-revenue activities that startups, or even pre-revenue for businesses that haven't launched the product yet. So before you go to market, you got to do research, you have to develop the product, and then you have to manufacture. Just a quick overview of what really drives product development. Kind of try to make it super easy to understand. There's 2 factors: the idea itself, and then the industry that you're, targeting to sell it to. Of course, entrepreneurship always has you have to think about the bottom line. So a lot of people get carried away with the idea, which is like, okay, let's just say, for example, I'm trying to make a smartwatch. Okay. A smartwatch, well, it's going to have an electrical component. So I think Jessica Jean Stone Cipher needs to come in. Okay, so yeah, smartwatch. So smartwatch needs an electrical component because obviously a screen doesn't light up and do commands, without a brain. It needs a mechanical component because you need to package all those products in there. Um, Potentially you need some software on there. So not only do you need code that runs the device, but you also need code that's on your phone for you to operate it if that's something that you choose. Now, what I just mentioned there, that's three separate engineers. Like the software engineer doesn't necessarily have the electro engineering skills, nor does the mechanical engineer have the other two. So, in this case, when I'm thinking of my idea for a smartwatch, I'm thinking, okay, I'm going to need three specific skills most likely to get it done. Then you want to, kind of refine a little bit better and say, okay, well, let me do some research and think about how I'm going to make it. So at a base level, right, you're gonna kind of know if you want metal or if you want plastic. That could depend on, if you need it to carry load, if you're looking for aesthetics, if it's cost driven. So thinking about how it's going to be manufactured also factors into the idea itself. There's many different manufacturing processes. It depends on the material and it depends on the function. Metal, we're able to 3D print in metal now, but traditionally it's been take a big block and subtractive manufacturing it down to the part. So it's a little bit wasteful, but that's just an example of something that you can do. And then timeline, of course, that's definitely something that, let's just say you think you hear the saying all the time of entrepreneurship and timing, how timing is almost more important than the idea itself. Well, for example, let's just say a pandemic strikes the world, and there is a critical window of 10 weeks where all the supply chains are upside down, and there's national mandates for masks that there's just not a supply chain for. Well, as an entrepreneur, you see an opportunity, you develop a product, but you realize that you only have, like I said, 10 weeks to kind of fill that gap before you have a lot of competition and a lot of the supply chain essentially fixes itself. So thinking about those things all tie into your idea. Now, the other component that a lot of inventors that are getting into this for the first time that don't necessarily think about is the industry. So these are kind of like bureaucratic type, process. Like I got to dot my I's and cross my T's. So if you're going for a medical device, you have to get regulatory clearance from the FDA if you're going in for the US market. They need to, they have a specific set of guidelines to submit your design. And those guidelines, there's literally thousands of different specs and hundreds of different divisions to design to, but it's like a between 20 and 30-week review process for the first time. In medical devices, you have different classes of it. All of these things factor into what I need to design to and for. And the reason I kind of made this slide labeled constraints is, there's like basically your product, if you think about it, is just a box, and the box has boundaries that are driven by your industry, but inside the contents of the box, how the form, fit, function of the device is the idea. So I mentioned a few different regulatory agencies there. There's ISO certifications if you're looking for high tolerance parts. ASTM, those are basically stress and strain thresholds. So there's a lot, and all of these have different articles, and they're all available free online to do a lot of research into. But I would say that it's very overwhelming the first time you do research because there's just so many different options. And then finally on this slide, we got market demand. So, if you're launching that smartwatch and the market and the customer expects a all stainless steel premium product, and that's what you're going to try to sell it for, then you have to make a device that fits that mold, if you will. Not to mention, sometimes you have two different pricing structures. You have value-based and cost-based. Sometimes you're just trying to be the cheapest and hit your margin and run volume, which is one strategy. And the other one's value-based. You created something new. You can make it for 5 cents, but the value that it has to your customers are $600. There's no reason to cut yourself short here, but that definitely guides your design to know what you should and could be spending your precious time and money on. So I will stop right here for a second. If anyone has a question, I know that was just like a lot of information. Okay, great. I'll keep going.
I have a question.
Oh,
Yeah,
yeah.
could you talk about, I guess you will probably, what the type of prototyping and work that you specialize in specifically, or maybe some case studies?
Yeah, absolutely. So we're just in the intro of the product development. Um, if you wanted a little bit of information on the company, let's see if this works. Can you guys see my screen still with the browser? Yeah, so our website hasn't been updated in a couple of years, but what we really specialize in is product development for inventors, small businesses, and we've even scaled up a little bit to larger businesses and being kind of their support outsourced engineering staff. Um, some services that we do, we have general product development, which spans from 3D modeling, 3D printing, testing, packaging design to, we do low volume, and now we're actually starting to take up some volume contracts with some new machines that we've picked up. But you do injection molding, machining, machine design, package production, and then we also have a service called fulfillment by RDM, which is, whenever, we're flexible with startups. I realize they don't have a lot of space. We can flow, their supply chain through our facility and fulfill their orders for them so they can focus on the marketing, the sales, and growing the brand. And then we also have a graphic design division that has, print work, websites, packaging designs, concepts for logos, renders, 3D modeling, and it goes on from there.
I have a question, if I may.
Sure.
I see under worldwide packaging, that looks like that might potential. I can't really tell. It looks like it might be a food product or herbal product. And I was going to ask if there will be anything specific that I can use today. I mean, it's all wonderful, but I'm wondering if there's anything specific for things that have an expiration date. I do like foods and drinks and things. That's what I'm trying to get into.
Okay. Are you working about RDM services in particular, or just in
Yes,
general?
yes, that would be great. Yeah.
Yeah, I mean, we definitely have graphic design for all sorts of products, and if you have expiry dates, those can all be incorporated into the design of the product. Um, I'm not sure. Is that answer your question, or
Yeah, I was just curious if, because I was looking at a lot of machine stuff, but now I see it looks like you have herbs. I can't tell what that is, but
oh, this was a product for like lotion. So
oh,
like
okay.
if you see there's a bug stick, a sun stick, and a skin stick. It's a lotion, a sunscreen, and a bug repellent in these capsules.
That's very helpful. Okay.
Sure. Yep. Yeah, and I mean, you can always, our tag is rdminnovation.com. Within the next couple of months, we're going to get a new website that expands into all of our services that we offer. But really what we want to focus, well, we kind of focus on being unfocused. And what I mean by that is we want to be end to end. So the services that you need that are technical in nature, that are back end pre-revenue activities, whether that be needing logos, whether that be needing prototypes, whether that be needing a clinical trial run, those are the services that we aim to provide. And yeah, so I'm going to get back to the presentation unless there's some more questions. Can everyone see the presentation again? We good?
Yeah.
Okay, great. Thanks. So here's a couple project management techniques. This is really kind of a lot of what we talked about, but really what I want you to take away from this slide is that product development gets broken down. There's a mountain to climb, and it gets broken down a million different ways depending on which company you use or what your personal preference is. But the gist of it is there are different phases between 1 and 7 phases that always have a start. They always have an end. There's always milestones in between to track your progress. And then I've also supplied, some little tips and tricks that we do to help us stay on track because projects are large. So we use Microsoft Teams for communications and like our Zoom. It's like our Zoom, if you will. We use Gantt charts through an app called Smartsheet that allows us to see how our timeline stacks up. And also we do weekly stand-ups where we talk to our team, seeing what risks they have this week and what they accomplished the week previous, and just kind of staying on the ball with everything because there's always a lot of stuff to do. Here's some examples. Like I said, there's like many different ways to break it down. Depends on your idea and it depends on your industry. Right here, this pre-study, initiation, planning, design verification. Right here, this is indicative of the medical design and medical device design process. So, as you can see, these are predefined phases. They each have, specific activities that need to be accomplished. If you can see, even though this is very similar, it's a little bit different in terms of when you compare medical device design to software development. So it plays back to creating the right work breakdown structure for your idea specifically, depending on whether it needs software, hardware, or regulatory clearances, or all three, or neither. Just depends. So here's some examples of ways to make your things in the real world. Prototype processes are very broad, but here's a few examples. There's a plasma cutter on the left, which cuts 2D shapes out of metal most of the time. You have an example of an SLA 3D printer, which actually RDM has in-house, as well as a CNC lathe, which also RDM has in-house, and a metal 3D printing. This looks like a model of an engine block. So there's a lot of really cool things. These aren't necessarily super scalable. Turning is, plasma cutting kind of is, but 3D printing is not something that you want to make 2 million parts of unless there's no other way to do it. Today, there's one thing that, make sure we're good on time. Today, one of the products, the case study, if you will, is EaseAlert. EaseAlert is, as a matter of fact, the smart device that goes on your wrist. It helps firefighters with pre-alert signals. So, the problem that presented was that, firefighters have anxiety, PTSD from, being in a deep sleep and getting in the fire station. They get, woken up with sound and visual feedback from the fire alarms. I mean, you guys jump out of your skin every time a fire alarm's pulled. Imagine doing that, 5 times a day, 10 times a day, and you never knowing when it's going to happen. So that type of anxiety kind of carries over, and they have high suicide rates. And, it's really just something that the founder, Blake Richardson, kind of identified because his father was a firefighter, and engaged RDM to basically take care of the product development services. And here's the product. It's called EaseAlert, and we're going to talk about it today a little bit. You can find them at EaseAlert.com. There's, really, really great. It's a really great cause. It's a really great product. And I'll give you a little update on where they are right now at the end of the presentation. But I'll get back to it, but just making sure you guys know that it's like a real thing. They're making progress. I showed you their website. Here, as you can see right here is a picture of one of their close to final prototypes. But it was a process to get there. I'll tell you that. So this is on the right-hand side. Here's some visuals. This was actually Gen 1 at the top right. As you can see, the wrist strap stretched through. It was at a point in which we were refining a lot of technology. Started out something to realize that you build big when it comes to electrical first. And then once you prove out how it works, you make it smaller. So it started out with a large footprint right here on your wrist. And then, it basically accomplished its proof of concept by having this touch screen that gets installed in the fire station. That got prototyped, and then it got miniaturized in another version. So there's 3 different iterations to show a little bit of what the product is. Now, some technologies that were used, we 3D printed the casings. We fabricated the PCBs, which are these printed circuit boards. Used injection molding for the straps, and found components off the shelf to save cost where we could. Like, for example, these screws right here in the bottom right-hand corner, you can see that's how the wristwatch attaches. No need to make a custom screw when a regular screw will work well, and is a tenth of the cost. So that's an example of the prototype process, how you go from V1 to V5 or whatever version that is. But getting into prototyping. So I made a really quick prototype checklist, which might be something to kind of think about. The phase of prototyping usually has a computer aided design model in it. It's 3D modeled. It allows you to not spend money on materials, but get to see different ways that the device can perform. And it's something where you start putting the pen to the paper, conceptualize it. You say, okay, I'm going to make it out of plastic or metal, and you don't necessarily need to know exactly what type of plastic, but you need to know some things, like if it's going to be soft, like it needs to stretch, or if it's going to be a hard plastic, or if your machining needs to be really tight tolerance, or if it's going to be experiencing a lot of load, you need to have some higher strength materials. And also that CAD model is going to help you identify what parts you must make custom and what parts you can just source in from different sources. Like, if you need screws, like I said before, or even there's so many marketplaces to find off the shelf parts. Alibaba is a great one. If you want to work with China a little bit and don't mind waiting for parts, you can get stuff for really cheap. And then, something that we kind of talk about is a proof of concept, which is Rev 1. That is your first milestone, second milestone after you make your CAD model. And that's where you're basically building this really rough version that accomplishes the bare minimum requirements across the form of it. So the shape, the fit of it, so how all the parts fit together, and then the function, how it actually works compared to what your expectation was. And then that final F there for feedback, it's super important. It's overlooked. You get obsessed with your idea and you don't really talk to anyone about it, especially not your final customers. But that is just, you're going to spend a lot more money keeping it shielded to yourself. Now you can do, like, if you're worried about intellectual property, get an NDA. It'll work. And people who want to know about your what you're doing and you need to get that feedback, a non-disclosure agreement is an excellent way to protect yourself while also sharing your idea and getting that feedback early on in the stages, so that in the next phase, it's not a compounding effect that takes a lot more money and time. Then you have your pre-production prototype, which it is a very general thing where you have V2, then V3, then V3.1, V3.4, 4, 5, that kind of thing. That's when you're basically tweaking it until you find the product. The prototype looks as close to the product as you're going to get without actually licensing it from your manufacturers. And then finally, you want to incorporate your design for manufacturing. So, this can be, not going into too much detail, but for example, in injection molding, if you have a flat face and you need to get the part out, you can add a draft, which means basically just angle that face. And if you angle it, you save $1,000 on tooling cost and labor time for a production run. So those are examples of what we've done in the past, where you basically, we call it DFM. You basically talk to your manufacturers. You say, okay, what's the most expensive parts of manufacturing this? They give you some insight. You tweak your design while maintaining the form, fit, and function of it, just to drive some cost down. And then you freeze your design. And that is really the end of the prototyping phase, is to say it is done with respect to the design. Here's like a quick, easy graphic to say what a prototype is not. So it's not one and done. You don't sell these. It's not perfect, and it's not the end. This is not the Mount Everest summit. This is a base camp. So something to think about as you are budgeting for your project. Prototype phase is not the end. It is simply, if you will, it's a go, no-go gauge for the rest of your project. What is a prototype? Well, it's a moving target. So that's something where, if you realize that you need to take some more time to improve the design and it's not mission critical, do it. Improve the design. It's a moving target. You want to put together a timeline and try to stick to as close as you can, but always consider what the value of adjusting timelines and adjusting cost is. And it's a platform, which is simply put, it's a great place for feedback. It is basically your microphone, your megaphone. It's something that you take to your meetings, whether it's an investor, whether it's a potential customer, and you talk about it and you say, what do you like about it? Well, what do you don't like about it? And you take notes on it. You prove through this proof of concept that you have traction, you've made progress in chasing your idea, and you are getting feedback to make the next version even better than the previous. And that's what really I mean by it's iterative. So, a case study here is that the founders of EaseAlert went ahead and got some prototypes, got a rev that they really liked. And when I say rev, I mean revision. It's kind of like how we track models on the technical side of things. Found a rev that they liked, made, I believe, 30 of them, went to a fire station in Fernandina Beach, I think San Fernandina for Fernandina, and got real positive feedback from the fire chief, ended up signing up to be one of the test sites for the product, and had really great discussions on how to improve it. So, I mean, if you can see on their wrists, there's different colors of it, and there's it has since changed in its design based on the feedback from this fire chief, which is super important to do now in the prototype phase and not the production phase. So I'm going to stop here. That was a lot. I don't know if I missed anything that you guys want me to cover on prototyping, but please let me know.
What's the typical cycle time from an idea to a working prototype like the one you just described?
Yeah, that's a great question. Now it depends on the project with respect to the design. So, and also depends on the budget. So you can pay to win in a lot of cases where you just keep pumping money at it if you want to get it done very quickly. You can have your developer, crash the project and put more people on it. But typically on multi-component, which means like 3 or more parts that need to talk together, you're looking at anywhere from 3 months to 9 months to get from idea all the way up to design freeze. That incorporates lots of feedback loops, a few different iterations of the prototype. And over the past, I think we're approaching our 40th project. And that is something that we kind of feel pretty confident on. Some projects, like one that we partnered with for a medical device, actually a spinal implant, it's still ongoing, but we're coming up on 13 months, which is really, really quick for medical devices. Those are usually between 12 and 18 months, with larger medical devices taking 24 to 48 months. So these are definitely investments, definitely lengthy. But you have it on the flip side where you can basically just give us a file if you have the 3D models, and we can just 3D print it and you can have it in 5 days. But what I just referred to is straight from your head on into the computer, into the real world, set up for production.
Domenic, Jessica Jean has a question. Do you have any good recommendations for prototyping methods for a product made primarily with wood and fabric?
Yes, I do. Depending on what the wood is, if it's just like a 2D design, meaning like there's not like a lot of crazy curves and contours, probably want to use a CNC router or CNC mill. That's a really, really great way to, machine down flat pieces of wood, or even, larger pieces of wood to get that down. And as far as fabric goes, I would go to there's a lot of local seamstresses, or, just looking on Google for fabrics. I'd say if you're trying to prototype and you're trying to do it by yourself and you have a lot of experience in that industry, then think about maybe getting a machine. But realistically, if you're just trying to do it quickly, make a proof of concept, and you're willing to spend a little bit of money to have someone take a look at the fabric side of things, there's a lot of options on Google that you might want to consider. There's another question. Yep, no problem. No problem. And definitely, like, I'll send my email in the chat afterwards when we finish, and we can connect if anyone has any follow-on questions or, don't want to talk in front of all the group. Not a problem. So if there's nothing else on prototyping, we'll move into production, because I think that's really the whole reason that you guys are here, is to know what is different from the prototype to production. And some of it's common sense, but I think it helps to just kind of spell it out. So you can see this nice little flow chart. You got design on the left, manufacturing on the right, and all these different big technical words in the middle. Essentially, this is just really trying to illustrate that it's a process to go from prototype to production. There's a little bit of crossover, there's a little bit of iteration, but they are two separate buckets that flow together and work together. So something to keep in mind as we go through some of these details. Just like prototyping, there's a production checklist. It starts with design freeze. You cannot start your production, or else you're going to start spinning your wheels. You cannot start your production process until you freeze your design. Some things that really consider about what actually defines a design freeze. You want a bill of materials, which is essentially every component of your product. And it could even be an Excel document. Every single component written out, the cost of each. That's it. You need to know what you're kind of looking at spending before you freeze your design. So make that bill of materials so you know what your raw material cost is. Then the other thing that you need in a design freeze, and there's a few other things, but at a very basic level, what you need is a spec, and that's technical drawings. So it's one thing to have a computer-aided design model of, like, let's just say this pen. It's a whole nother thing to have, the angle of this clip defined. It's a whole nother thing to have the material selected for, this thread piece. It's a whole nother thing to have the thread count and the pitch and all that defined for, that component. And it's a whole nother thing to say how tightly you want to spin it on, if you will, like a torque. So those things need to have technical drawings, which is a way for a manufacturer to verify that what they're pulling off of their machines will meet the requirements of the device whenever it gets assembled. So that's called spec. Now, after you freeze your design, you start your supply chain setup. Now that's, requesting for quotes across manufacturers and distributors. Custom parts need custom manufacturers, and there's a lot of them depending on your industry. Distributors, you might be able to find some off-the-shelf stuff, or if you need to license some technology, those are the kind of things that you're kind of doing in the initial supply chain setup. What vendors for what parts and how much is each going to cost in reality, including shipping to get to where you're going to be. Where are you assembling your final product? If it's a one-part product, then you're good. If it's not, then unless you have a really great manufacturer, you are going to have to get all your different parts, flow them into one point, and have someone assemble it, or many people, depending on the volume of your operation. Then you start thinking about how much time you need for each assembly and how it would get done, whether you need to do bulk order processing or whatever it is. And then your order fulfillment process. So all your packaging, final costs on that, how it all works out. When you have your supply chain set up, you'll know exactly to the penny how much it costs for you to make your product, to the penny. Remember, like, business is a formula, and without having the details, like your cost of goods, you don't know if selling 1,000 is going to make you a millionaire or bankrupt you. There's definitely situations where people don't look at cost of goods. They don't take the time to do that, and they realize later down the road, after hundreds of thousands of dollars and lots of inventory, that selling it is the worst thing they could do because they're losing money every time. And then finally, production really gets kicked off when you have an inventory management system, a quality management system, and then later down the road, enterprise resource planning. Now, those are all acronyms. You're in production when you have a ton of acronyms that you need to abide by. I have examples of different IMS, QMS, and ERP systems that you could use. They're all have different costs associated. They all have different functions associated. But to really be efficient in your processing of your product, you might want to consider having a system instead of just kind of like throwing it all in a corner, getting an order in, getting it done, shipping it out. And that's kind of the production checklist. It looks like we got about 5-ish minutes left in time, 10:30 to 11:15, but because I definitely want to leave some time at the end. But this is just a quick diagram. We only got a couple charts left, so bear with me. This is a quick diagram to kind of explain what we just talked about today with respect to product development being the overall umbrella. And then you narrow down product development into prototyping, which gives you more traction on the idea. It puts basically pen to the paper, and it allows you to formulate how that prototype transitions into production. So systemizing, standardizing, and basically launching your business, product launch. And then it all is all of that product development, prototyping, production. It's all centered around your product, which your product is all centered around your idea and your industry. So that is kind of like a top down. What does it mean when someone asks you about product development versus prototyping versus production versus what your actual product is? This is like, kind of like almost like a Venn diagram of how each of these are different. So when you have a prototype, you're iterative, you want to have feedback there. You want it to be, shifting, adjusting, flexibility, that kind of stuff. And in production, you really just want it to be put good in, get good out, plug and play, plug and chug, that kind of thing. The prototype's driven by your design, so that the length, the cost, timeline, everything is design driven. In production, you have cost basis, which suppliers you choose, how it gets done, the method of processing, assembly, everything is going to come down to cost for the most part. Now, there's also a quality component. You don't want to go so cheap that you end up with an inferior product that never works, but there's a balance you have to play. But mostly it's cost driven. And then prototyping is subjective. So, the whole saying of like, what does done mean? Done means done. It's kind of subjective. You can always spend more money on a prototype. You can always make another rev. You can always improve it. You can tweak it. But you have to decide what's best for the product and project timeline, cost. You might be over budget, might be over time, might be under budget, under time, and that will play into your when you kind of lock in the design and the design freeze. Production's objective. It is black and white, A or B. It's I'm going to go with you because you have better quality and lower price, or I'm not going to go with you because of the opposite. It's very simply put. There's no icing on the cake. Get down to the nuts and bolts and get it done. Prototyping is typically lengthy, like Carl asked about timelines, 3 months, 9 months for designing, for iterating. Production is not so much time. It's not so much time component that weighs in on the startup, but it's cost. You got to really think about how much inventory you're going to store. Usually, lead times for different components are 4 to 6 weeks. So if you submit designs, you'll be able to get your first 500,000, 15,000, depending on your manufacturer, back in 4 to 6 weeks. It's costly. Those ranges, it all ranges. You have tool, which is your setup cost, and then you have your per part cost for production. And one of the last slides that I have here is progress report on EaseAlert. So they're not in production quite yet. They're entering the design freeze, but what they were able to do with the prototypes and the prototype phases is that they were established in two test sites. They're going to be the first orders, and they have 15 fire stations that have signed letters of intent, which means when it comes hot off the press, they are going to be purchasing. So that is very good traction. It was very helpful for the project. And they also got essentially this feeling from these fire stations that they're going to be early adopters. They're going to be part of something new, innovative, and it got them excited about the project. So when it does go to market and they do go to production, they already have the initial batches sold, which is it's a technique and a tip that you might want to consider for your own startup if you're hard pressed for capital. You can take letters of intents to banks for loans. You can get better investment, things like that. With that, right on the money, it's 11:15. appreciate everyone's time today. I am readily available for questions. I'm going to put my email in the chat here so that you got click the exit so that we can connect later on if you need to. But what questions do you guys have? If you have it.
Yeah, a question is on the EaseAlert. Is it wireless Wi-Fi, or what? How do they actually transmit the signal from the wristwatch or the device to the computer?
So the device has a few different protocols. Not going into too much detail, but it has Bluetooth connectivity that
Okay.
allows for device-to-device connection. But they also have some proprietary protocols with respect to communicating. Those fire stations get signals before the alarms go off, and they are able to create some proprietary protocols to tap into that data communication source
Cool.
and then display through Bluetooth.
Sounds like a great idea. Sounds like it be used, around not only around the U.S. but potentially around the world. With I'm sure other fire stations around the world have the same problem.
Certainly.
Well, any other questions? Well, Domenic, as usual, you did a great job. I mean, you're a great presentation. We'll follow up with an email. Elena will follow up with an email about getting in contact with you of anyone who's interested. And if you have anything you'd like to give Elena to share with the group, please do that, and she'll send it out. And and we really appreciate you doing this presentation. And as always, it's prototyping is the main thing. I've personally experienced many times that, and with other startups, that when you talk with an investor, the first question they ask is, who are you, the CEO? Who's your team? Do you have a prototype?
Right.
Can I see what it is that you're going to do? And the thing too that I always encourage startups to do is develop a prototype of what the vision is, even if it's not a fully functional. It shows them, the investor, a vision of what the product could be, even if it's just a box with some lights on it, right? But they kind of get a grasp of that. Don't show them a breadboard with wires sticking out of it, and it shows them that you're still wiring it together. Okay, don't show them that, because they get nervous. So it's always good to show them the final result, and the only way to do that is through rapid prototyping and what you guys do. So but anyways, thanks again for everything, and you all have a great week. And next week is Santa Fe is on spring break, right, Elena?
Yes.
So we won't have a webinar next week, but we'll have one the following week, and we will have our pitch tape webinar at some point here, sometime in the near future. We'll let you all know. That'll be a really exciting one, because you will see how any entrepreneur at whatever stage you're at can put together a presentation and pitch to investors, especially if you have a prototype. So everybody have a great week. Thanks for attending, and we'll see you in 2 weeks.